You started off in chemical engineering, Bala. Do you remember things from the course?
Oh, very much. And I kept remembering because I used to be a teaching assistant in chemical engineering when I was doing my master's. So basically, I had to teach a lot of undergrad classroom. And again, you got to go back. Only thing the textbooks were different, the concept was the same. So the style of teaching was still kind of surprising because I did my master's in the US, and
Okay.
the US students have a different approach to undergrad studies compared to the Indian students. So when I tried to kind of use the same Indian methodology in the US, it was a surprise to a lot of American undergrad students. So
Okay.
what they learned, like for a simple example, would be if you're doing a study on distillation columns. We used to use regular old style graph paper to do things. The Americans used to use software to do all those kind of things. So when I
Okay.
gave them a graph paper, they could not make head or tail of it. But I made them do it, and things like that. It made me remember a lot of my engineering things.
Okay. Okay. So I'll make the introduction and come back to you, Bala.
Yeah.
Okay. For those of us who do the simple things, there is a cliche. It's not rocket science. But what about real rocket scientists? Bala Madhan is one. His profession is rocket engineering, aerospace engineering, and he's involved with advancing solid, liquid, and cryogenic propulsion, among other things. He works on hybrid rocket motors, designs composite structures, figures out heat transfer and kinetics, and investigates computational and transport phenomena. Most of us have a limited understanding of these concepts because our experience is confined to watching rockets blast off from various bases around the world. But today we'll have a chance to understand this a little better as Bala gives us some down to earth explanations of how he got into this career. And for any of you aspiring rocket engineers, settle down and go over this episode a few times. He'll also tell you about the kind of temperament and the skills you need to succeed. His perspective, I'm sure, is quite different from what is taught in classrooms. My name is Venugopal. I head Ideascape Communications, and every week we travel on different career journeys. And today, I'm sure that it's full of twists, turns, and excitement of real rocket launches as we figure out how Bala got into space science and what are the things he's doing right now. Welcome to the show, Bala.
Thank you.
Okay, so you started off finishing your chemical engineering. Before that, did you have any other career aspirations? Were there other things that you were thinking
Oh
about?
no. Traditional chemical engineering was what I was doing after my graduation. I worked in the tire industry with Dunlop tires at that time. I was
Okay,
a technical engineer coordinating between the shop floor factory in Ambattur, where they had their productions, and then in the field also trying to analyze tires. Like they say, must have I can look at a tire and tell what is wrong with the tire visually. I must have seen at least more than a million failed tires. And my job was to identify what caused the problem, get back to the factory. And at that time, there was a concept called Kaizen, which is a what do you call a tool that is used to streamline defects in factory line. It was a Japanese technique. So
okay,
we were kind of tasked to learn the technique and report back to the factory on how to reduce these faults and things like that. So that was the start of my career. And then from there, that was traditional You go and I used to even get ragged, you would call it, in the factory when I first started my career.
Okay.
They they put me onto the shop floor where they manufacture these huge truck tires, and
Okay.
you don't realize it by the end of the day when you get back home, your whole, including your ears and everywhere, there is carbon black particles in it. To wash it
Correct.
off, you have to have a hot water bath and it would take 30 minutes. That happened for about a week, and then I noticed the shop floor guys were playing around with me. So that was my start of my career.
What
Then
did they do to prevent this happening? Or what were they?
they were given masks and things like that.
So they asked you to work without a mask as part of the ragging operation.
Basically, not work, be around the workplace.
Okay. Okay.
So it was kind
That's
of
good.
a learning experience, but it was a very challenging and interesting work that I did with. I used to travel a lot since I was the regional service, deputy regional service engineer for the whole of
Okay.
South, which means I covered about 5 states. I used to
Okay.
start my week by traveling, picking a state, traveling the whole week. Sunday night, take a bus, go to a particular, like say Bangalore, go there, and then spend the next day there, take the night bus to Hubli, and it used to be like Dharwad, all the offices in Karnataka, come back again on Saturday morning. Then the routine used to be Sunday again the next day. So it used to be travel, travel, travel throughout
Quite
almost
hectic.
like almost 4 years of the time I worked in Dunlop. That was almost the last end of Dunlop before it was kind of closing down. Now Dunlop doesn't exist in India. But it was a real nice experience because I got to see and meet a lot of people traveling through the entire thing. I've, in fact, to meet customers, I used to suppose in the interior, a tractor customer would come back with a complaint. So I used to take a
Okay.
bus from Madurai to the outskirts village. Then there, to get to the path where his house is, I used to rent a cycle and pedal 5, 6 kilometers to reach his place. By that time, that person would have filed a complaint with the consumer court. By the time I
Okay.
reached, they would be kind of surprised to see somebody responded to their complaint. They would forget about the complaint and things would get settled. So it was a very different kind of an experience. I did that
Absolutely.
for about
Absolutely.
3.5, 4 years. And then I moved on to industrial coatings, paint industry. So this is
Okay.
basically coatings for high-end industrial applications like pencils. You think pencil is just a ordinary coating on that pencil. It is a high specialty coating. Things like shop
Oh,
floor coatings and things like that,
okay.
and machinery coatings, and a lot of that was done. Plastic coatings. I worked a lot on that R&D. Then I kind of I worked in India for about 6.5 to 7 years. Then I got to the point where I felt a job was getting monotonous.
Okay.
That's where I decided to switch paths and do something more interesting. And there is a history or a background on why I decided that.
Okay.
And the main reason was when I was a student. This was when I was in the third or second year. I don't exactly remember the time. It was something around the 86, 87 time frame. I used to come back for my vacation from college in Manipal and come back home to Chennai taking the Mangalore Express or the other
Okay.
West Coast Express or the Mangalore Mail. I don't
Right.
remember which exactly the one I took. I think it was the Mail. I
Okay.
encountered a person traveling with me on the second class compartment. And he is, I think, between Shoranur and Podanur or something like that. So memory is still there, but still vague in some aspects.
Okay.
So we got started talking, and then this person was talking about aerospace and things like that. which at that point in my life I had not heard of aerospace or anything to do with it. But
Okay.
I spent about 45 minutes before he got down in the next stop. And that conversation, he had mentioned that there is a university in the US, and this is that he was talking about a person called Werner Von Braun, who's
Okay.
the father of rocketry, basically. And this person was the person who developed the rockets for NASA for the moon missions and things like that, moon landing. And then the conversation, I just slipped out of my mind. I
Okay.
continued on with my life and my career. And then
Okay.
after all these years of working, suddenly I said, why don't I do that? And I had kind of saved up enough money to fund myself to go
Okay.
to. Normally, the tradition now is in India, the moment a student kind of graduates from undergrad, like say BE, he normally starts writing GRE, TOEFL, and starts looking at
Yeah.
going for higher studies in the
Yes.
US. At that
Right.
point, it was, and we didn't have internet at that time to do all these kind of which university should I go to and things like that. So when I decided to do my masters, I didn't. I had accumulated some money to fund myself, and
Okay.
but still, people were kind of telling me that you're 8 years into your career. Why do you just want to throw it up and go abroad and take a chance, basically?
Right.
So I used to spend a lot of time in the American consulate in Chennai. They have a library.
Right.
You go there, they have all these huge books with all the universities, what is the cost. And I went through a lot of them. Then I finally remembered at that point, this person
Not
in
to.
the train had asked me to go to one particular university. So
Okay.
I picked one particular university and I applied for my master's there. I didn't get funding, scholarship as they call it. And so I went to the, it was, again, there was no internet at that point. Internet was starting. This was in around the 97 period time frame. Internet
Right.
was just a thing. So, and I didn't have a very good hang of computers and things like that. The maximum I could do was maybe an Excel sheet or a Word document. Beyond that, no knowledge of computers. And that too, we didn't have computers at home. We used to go to the office computer and do some if you need things like that. So I
Okay.
applied for this university, and at that point, the application was $35. That was a big amount of money at that point of time. So I
Right.
applied for the university, and surprisingly, I got an admit in the university, but without any scholarship.
Okay.
So I packed myself and to an unknown destination. It was a small town in a place called Alabama, Huntsville.
Okay.
So I didn't know where to go, whom to meet. Luckily, there was a thing called Indian Student Association in that university.
Okay.
So I mailed them saying I'm coming. Please help me. So they said, okay, you come. And the closest airport to that place was Atlanta. And it's about 3.5 to 4 hours drive from the place where the university was.
Okay.
So I get down of the airport. This is the first time I'm flying abroad. I get down, and then there is this person in a beaten down car, an Indian guy.
Yeah. I remember these stories from other cousins. Yeah. Please go ahead. I know it's crazy how many people have had to do this, difficult
Yeah, it is. And it
integration
was
and
challenging
assimilation.
because you don't have this kind of current infrastructure that was not
Nothing.
available at that time. So it was
Yeah.
like, I don't know if this person will be coming to the airport. I don't know what to do after that kind of a scenario. But this person
Okay.
came, and I remember we drove down all the way from there to the place where my university was, and we were housed in along with six people in a three-bedroom house, which was
Okay.
in a bus, uh, which was in a the town basically, the cheapest part of
Okay.
town,
Great.
and I had enough money to pay the tuition fees and survive for 6 months, and
Okay.
that's where I started. And we had to go to college 3 days a week basically to attend classes. Most of the masters were in. I did my masters in chemical engineering. So
Okay.
basically, what happens is you go to class in the evening, and unlike the Indian system, the system there is very different. They give you homeworks every day, and you got to submit and return the homework by next day. So you
Oh,
got to keep on studying throughout the week, basically. It's not like in India where midterms, end of the year, exam time, you
after that, you
cram
don't touch the
everything.
books for another couple of months. Yeah.
You don't touch the book. You
Yeah.
enjoy your life, and then last minute you go into that cramming mode.
Right.
That is not possible there. And another big challenge I faced was at that time, all the like your homeworks, the way you do your calculations, everything was using software. So that was again a bit of a challenge. And the other big challenge is you are sitting with people who are much younger to you
Right.
in the classroom and trying to catch up with their thing. And again, it is not an easy thing after you work for a long time and getting back into a classroom and kind of the mode is entirely different. I
Very true.
did so. The This is another thing which is still happening, and they're cracking down on it. A lot of these students they kind of focus more on how do you get to earn money to keep your sustenance in the thing. So you get to do outside jobs like working in a motel or working in subways and things like that. I didn't do that. I said it is a go or no go, and I spent all my time in the library trying to learn things up. At the end of
Okay.
the first semester, I they have these grades called A, B, and C out there. So A is the best grade. So I managed to get two A's and a B, which managed me to get a teaching assistantship, a half teaching assistantship in the college. That means you teach some lab or something. But what it did was it provided me a thing where I don't have to pay tuition fees.
Oh,
And so that is basically at that time it was about $5,000 to $6,000 a semester. So that was a big thing. And you get a TA assistantship of about 300 to for half TA or 300 to $400. So
okay.
that was my first, what do you call, barrier I broke through. So
Okay.
once I
Okay.
had that, I had the confidence to, in the second semester, I kind of did everything pretty well. So immediately I got hired by who was doing research work on something in again in chemical engineering, but affiliated to aerospace. It's a part of chemical engineering called catalysis they call it. So it's a pure chemical
Okay.
engineering thing. Catalysts are common things they use in petrochemical industry and things like that. So that was the first start I did. But again, the application was entirely different. It was for aerospace applications.
Okay.
So I that provided me a full research scholarship, which means I'm a full, not a half assistantship, which was like double, maybe about $600 a month or something like that. And
It's a real step
it
by
was a
step. You were moving
step
up.
by step. Yeah.
Okay. So I'm speaking to Madan Bala, who began by doing his chemical engineering at the Manipal College. And a chance encounter in a train is when he first got to hear about aerospace, because he wasn't really aware of what it meant at that particular point in time. We're talking of the 80s. And that 45-minute journey he remembers. So he first got into Dunlop, and then he says he's seen millions of tires and can instantly make out what's wrong with the tire because he was involved with figuring things out on the research part of it. He also did a lot of travel and met customers across, and then he got into industrial coatings. Now, you might wonder what a career that started off in chemicals, in tires, and then went into industrial coating could actually evolve into a career in aerospace engineering. And that's the wonderful part. 8 years after he began working, Bala decided on his own to go ahead and do his master's in the US. It was a big decision, a big leap. And at that point, the internet was still in its infancy. He figured out all the methods by going into USIS library in Chennai and then figuring out what were the colleges and which places he needed to get into. He got admission, but he could only finance himself up to the first 6 months. And then once he got there, he clawed his way into the next level and the next. So now we're going to find out how Bala figured out the way ahead into aerospace and how did that come to be a part of his career graph. If you've liked what you've listened to so far, please listen, please share, subscribe, and spread the word, because people need to know that these careers are not built in a linear progression. There's a lot of thought and there's a lot of switching that happens mentally as well as in terms of what you're doing on the course to try and figure out how to get ahead. So let me bring Bala back in. So you got there, you got a full assistantship, and then I think by the time the course was a couple of years, so you managed it. How long did
I,
it go on?
the master's was basically a 2 year program, and I was finishing up my master's maybe a little ahead of time. And it
Okay,
was basically, I there are two options of doing your master's. You could either do a course curriculum and then finish, or you could do a research option and you could present the research as a curriculum part. So
okay,
since I was doing the research part, like I said, I was working on a project for using catalyst development for
right,
a lot of aerospace applications, especially rocket motor igniter applications.
okay,
Any
okay,
rocket motor is first got to be an igniter. That's a separate part of the system itself. So my research focused on using that. This was all before the pre 9/11 scenario, where
right,
we could walk into NASA centers and things like that as an F1 student. And then basically I finished my master's, and then you have something called an practical training program,
okay,
OPT they call it. They give you 1 year.
right, right.
So I kind of was searching out for jobs, and then 9/11 happened. The
Oh,
moment that happened, they stopped allowing people to work in experimental aerospace, and access to facilities and things were cut off for foreign nationals. So that made a big challenge for me. And technically, normally, very rare, not very, very rare for, it is still very rare for people in this line of work to get H1B sponsorships at that point of time. Even
right,
now, I think it is if you are in this particular line of studies, it is not easy getting a H1B, because H1B requires a minimum. No, any job in the aerospace related industry requires a minimum of a green card. And once this happened, I was kind of left with the option of either returning back to India or doing something out there. So at that time, one of the committee members in my master's thesis committee, he suggested, why don't you get away from your experimental things and start looking at computational things? So he hired me as a research assistant for PhD to do in a field called computational fluid dynamics. And at
Okay.
that point of time, again, I had no idea of what software coding, computing, anything, nothing of that thing. And the entire concept of computational fluid dynamics is basically developing, taking experimental physics models based on experimental results and converting them into computational codes using an outdated, I don't know, they still use, I think, programming language called Fortran 77 and Fortran 90. So that
Where
was
did this
again,
find application?
hmm? See,
Where was this
again, where,
applied?
oh, it is used everywhere nowadays. And you got to understand in aerospace, it is to do an experiment, it is not a cheap thing to do. It is an
Right.
expensive affair. Even a small experiment costs money. So what people do is they simulate the experiment and try to get some idea of how the experiment would, basically an extrapolation of what it would be, and then go back
Okay.
and try the experiment. So it's a back and forth between the experimental and the computational thing. And luckily for me, it was like when I was thinking of not doing it, I said, let me do it, which is like, again, one of the most positive decisions or the best decisions I've ever made in my career, because a lot of people who are experimentalists are not good and understanding what a
Yeah.
computational
Right.
person requires. And a lot of
Yeah.
computational people don't understand what the experimental person needs or does. So I bridged the gap between the two. I was an experimental guy who jumped into the computational field basically. So that gave me a lot of what do you call added advantage in the future. So and again, it was not easy. And normally, a person doing a PhD in the US starts with his master's and then goes on for 6 years on the same topic. It is
Right.
not a different topic at all. It is the same. You continue till for almost 6 years. So I kind of again was stuck in the thing where I was saying like, okay, I got to do 6 more years. And but thankfully for me, my advisor and me worked this thing. So I learned and we developed some new models on a topic called. You normally use a thing called spray atomization, and you look at it, a garden hose sprays things, automotive
Right.
injector sprays things. So it's a spray is a it's a part of any, it's a chemical engineering process again. It is a process where a droplet is sent into the atmosphere and heated up, and the droplet evaporates and combusts. It's a chemical, it's similar to your distillery factory. It's a distillation process, only thing in a different environment. So what I did was my PhD focused on taking one single droplet and tracking how it evaporates using computational fluid dynamics. So
Wow.
that was something, and again, it was quite a challenge, but I was able to complete my PhD in about 3.5 years.
Okay.
The advantage was once I started doing this, there is again coming back to the basics again. There are three main aerospace research centers in the US. One is at Penn State University, one is at Indiana University, Purdue, and then the third was in Huntsville, Alabama. These are the main places where, because both the military and the NASA people have centers there. So it was these universities were the prime locations for these kind of research. So when I did my PhD, the research center that was, it's called the Propulsion Research Center, immediately funded me to do this and with full scholarship.
Okay.
So, and the center's director was I could call him my a mentor in the US. He encouraged me to publish and do things. He said, just ask me what I need to do. I will get it done for you. That kind of a backing he gave me.
Wow.
And I did my PhD, did my, they have this dissertation defense, they call it. It's a 1 hour operation where a lot of committee members and outside faculty come and start questioning you on your work, basically. It's a challenging scenario where
Right.
if
Right.
you, if a professor feels that my thought processes or whatever I'm doing is not in his line of thinking, the questions get more and more, what do you call, deep and penetrating. And so you got to be
Right.
prepared for all of it. So
Right.
I did do my defense. And you're basically kicked out of the room after your defense. And they have internally, they will decide whether he's funded or he's passed or not. So luckily for me, I did manage to pass that PhD. And 5 minutes after the defense, and when the rest of the people have gone out, the center director, he offered me a job in the university with the
Within five
industry.
minutes of getting your passing
I had known him,
news report.
but he had
Yeah.
also known my abilities. So he said, Bala, here you are. Come tomorrow, take your offer letter, kind of.
Wow.
And Uh, the best part of doing, there were other options of going to the industry and working for companies like Siemens and others who are doing all this industrial modeling, developing modeling software like ANSYS and things like that, where you could go get a job. But you would be basically doing a lot of coding work, which I was really not interested in. I cannot sit in front of a computer for more than 3, 4 hours at a stretch. That is beyond me. I'm talking in a week. So that was beyond me. I would
Okay.
like to be in a laboratory building things and testing things rather than sitting in front of a computer. So
Okay.
I did do it though, and they offered me a job with the research center. The advantage with the job in the research center is you go under a different category of H1B altogether. There are no quotas in a university system. That is one
Right.
thing. And when the university files your green card for your green card, you go under a different category called EB1, which is
Okay.
basically eminent scholar category.
Okay.
So it is not like your regular H1 to software kind of a thing where it takes perpetually eons to get your green card. And it is getting more and more difficult where the wait list is almost 15 years now. So and advantage with me, they said you have to wait 1 year. You can't leave the job in between. And you have until you get your green card and all that kind of stipulations they put on me. So I said, okay, and I know the place and I worked with the people. Now the only thing is I'm commanding the students who are working in internships in the lab and things like that. It was a very congenial and very learning atmosphere where new people come, you get with ideas, sit to work with them. And I built the first test facility of its kind in the US for the center, where I was tasked with building a liquid oxygen, liquid methane. At that time, it was starting to come up. The concept of using liquid methane was used, liquid paraffin and things like that came up. And I was tasked with building a university setup to do those kind of research thing. I was given about $500,000 literally and said, go build it. I did build it. And in between that, the green card application was also going on. The advantage with my thing was since I worked in a lot of defense related areas with the university, you have something called recommendation letters that are needed for your green card. So most of the recommendation letters I got were from, like, say, a colonel or from the Air Force or the some military person. That made
Okay.
things a lot easier. I got my green card in about 4 months.
Oh,
So, and I worked with the university for about 2.5 years still. Till 2011, I was there. And then end of 2010, I was there. And then this group from I used to participate in a lot of conferences. There are two big conferences with regard to the aerospace industry. One is called the big institute is the American Institute of Aeronautics and Aerospace. That's the prime institute around the world for these kind of meetings and gatherings. And they used to have two conferences, one in January and one in August. And as a part of my thing, I was put into several committees in these organizing committees. So I used to get to travel, paid for travel through the university, make presentations, organize sessions, and things like that. So that way, I got into connect with a lot of people from outside my environment, who are basically you could call them movers and shakers in the industry.
right.
So and I used to chair sessions, and like I said, I was a part of two subcommittees or committees in the AIAA. One was the Hybrid Rockets Technical Committee, and then again another one was the High Speed Air Breathing Propulsion Committee. So hybrid rockets. Let me explain. That was I used to do a little when I was in the University Research Center. We used to do a lot of work for developing rocket fuels and then
Propellers.
liquid rockets. People, let me give a brief what do you call distinguishing these kind of things. A solid rocket is something like a Diwali rocket. So you basically have a solid and it has a limited range it can fly to. You light the rocket, it goes to a particular place and it just goes off. So that is one thing. It is kind of very toxic. The making of it is, it's got a lot of chemicals. It's got a lot of toxicity associated. Storing it is a problem. Destroying it is a problem. So there are a lot of issues associated with it. And then the other end of the conventional thing is something called liquid rockets, where you have things like for example, your PSLV is a solid rocket in India. ISRO does its PSLV. It's a solid rocket system. Multiple solid rockets stacked together to form the PSLV. The other end of it is something like your GSLV, which is basically liquid rockets. So liquid rockets require a lot of, we call them in lingo as plumbing. It means you need a lot more, uh, like I said, valves, control systems, and all that, because you have two liquids that need to be pumped in at a particular pressure and flow rate and things like that for making the things happen. It is pretty old fashioned, but it's well understood. But it is very expensive because the components associated with it are pretty expensive to manufacture. And then you have the third part of it, which has been there from World War. It's invented by the Germans. It's called hypergolic system. So even the GSLV has got hypergolics. You take your Agni missile, it's got hypergolic system. Hypergolics are basically two extremely toxic liquids. When you don't even have to in a liquid rocket, you got to ignite the liquid still. It does not burn by itself. In a hypergolic rocket, the moment you put these two toxic liquids together, it just burns. The only problem is when you see a launch of a missile, Agni or something else, the North Korean missile, you will see a toxic orange fume around it. You cannot be anywhere close to 20 miles around those fumes. It is so
Wow.
toxic, it will burn through everything. It is pretty well understood. It is still used in India and because it's pretty well understood, but it's extremely environmentally harmful. So the idea to go away from all these technologies is to take the best aspects of both and to incorporate them as a different type of a system. That is what we call as a hybrid system. We take the aspect of solid where it is easy to store. It's a solid part, easy to manufacture in a way. And you use the oxidizer, they call it. The fuel is the solid part. The oxidizer is the liquid part. So the moment your oxidizer and the fuel combine, that's where the actual rocket starts working. So this was a new concept developed. It was developed pretty long back, but not mature enough. So there was this group from Stanford University who were the first to develop something because again they were using old style rubber as fuel and things like that. So there was this group from Stanford University that used to interact with when I used to go to these conferences, and they were doing these new type of uh, hybrids using ordinary candle wax instead of other things. Imagine
Okay.
just burning, you're burning basically the rocket with a hybrid motor, especially a paraffin wax motor. You call it the biggest candle in the world. So the motors are maybe 4 5 meters long, kind of a thing. And I had
Incredible.
done some
Okay.
hybrid work when I
Great.
was in the
So,
university.
Bala, let me just make those announcements at the next time and then come back to you.
Yeah, sure.
So, I'm speaking to Bala, and during this time, he expanded on how a combination of uh, his capabilities, the time of his arrival in the US, and the general environment contributed in equal measure to him finishing his PhD and then getting recruited by the same university within the next 5 minutes of getting his PhD as well. Now, from there, he spoke of how there are so many aspects to simply understanding how rockets are launched. And he spoke about solid fuels, liquid fuels, and how he's has worked out a hybrid form of ensuring that rocket propulsion can happen. I don't understand a lot of these things, but for people who are in the space, I think he provides absolutely clear indications of why he opted to do what he did. He also spoke about the importance of networking and how his shift between being in a lab and simply being experimental and actually seeing it implemented on the ground by going to these various conferences and chairing them, writing papers, expanded his network and got him in touch with a whole lot of people who could make things happen, the movers and shakers, as he calls them. So if you liked what you've listened to so far, please share, subscribe, and let your friends know. In the final segment, I'll be speaking to Bala about what current opportunities are there in aerospace, what kids today should be doing, and what are the things that work as far as the temperament of being in this profession goes. So, Vara, there are a lot of aspiring rocket scientists out there, kids who are just starting off. So, what would be your advice for them?
Like I said, the opportunities there are much more what do you call widespread nowadays. Especially, you got to understand aerospace does not mean aerospace alone. It covers an umbrella of different sciences that can be done. Like for instance, when I was doing a lot of work with the Stanford group at Stanford in the Bay Area, I had no idea what composites was, carbon fiber, fiberglass, and things like that. So that's where I started understanding what these are, especially when you're talking about motors, and they call them flight weight motors. So you cannot have a steel structure because they're very heavy. So these things need to be fiber wrapped and things like that. So I used to spend time in the shop floor with the people who knew what they were doing. In fact, I've lost a lot of nice shirts because the material used to come and stick on me. Yeah, just fly around and stick on me. So I used to spend time understanding how the process is done. So I kind of learned that skill, there's another aspect of it which is called finite element analysis. This is something different from, it is again a computational methodology, but it does not involve something to do with fluids and things like that. It is more to do with materials. Like, for instance, if I use a carbon fiber wrap or a metal casing or whatever, I need to know what the stress loads are on them. So you use software called ANSYS or other softwares are available. You start learning on where the stress points are. You kind of mechanically redesign based on your inputs from these things. Again, here's the
Okay.
fundamental thing with engineering, especially since I did both the mechanical and the experimental and the computational part. uh, Computer software or any software that you use to or do all this modeling is basically like the common thing you say, garbage in, garbage out. So the better the data you put in, the better your answers would be. So the best way to do it is take the best part of your input from your experimental people and find a way to input them in this computational model in such a way, even if you get 60% of what you expect from the actual reality, you can extrapolate it. Again, the extrapolation is something which I'm kind of good at because I've done both of them. If I had been only in the experimental, I would not have been able to do it. If I had been only in the computational, I would not have. Since I know I've done both, I can say, okay, I can say if my model is 65% accurate, I can extrapolate it to such an extent, say maybe 80%. That saves a lot of money from the experimental side as far as doing the next test goes. So that's something you learn along the way. Those are kind of things you learn. And then there is aspects of actually doing electronics also. So I've built for electronics means you have these sensors, thermocouples, pressure gauges. All these are a part of electronic systems that are used to control the flows and things like when you're doing a rocket launch, the guidance and navigation. Guidance and navigation, I'm not an expert, but still there are aspects of it which you could learn. But the other aspects, making all these thermocouples and things like that, that comes as a part of electronics. So I was along the way in your office, you see some electronics guy making these things. You sit with him and you learn things. So it's always, you got to understand, anything you do is a cross team effort. You just cannot individualize and compartmentalize yourself. So when I was working, especially when I worked with the Stanford group and then I moved on to a next project, it's a place called San Diego, which was very attractive compared to living in the Bay Area. And I picked
Yes.
San Diego for a company that was doing work for what is now flying as a Spaceship 2, which is Richard Branson's tourism company.
Oh,
It's a company called Virgin Galactic, and they were
right.
doing this hybrid rocket, even though the hybrid was not paraffin. It was a different style of hybrid. I joined the team in San Diego and worked on that for almost 2 years. We developed that motor, and it is really nice to see that the motor is human rated and carrying passengers up in the sky. Because till date, India has not got a human rated rocket motor. So
Right.
human rating is basically, even if you have point not 1% problem in your rocket, if there is a human in it, it is not acceptable percentage of a failure. It has to be 100% accurate. So that was a nice thing working on that project and seeing the Spaceship 2. You can go to YouTube and watch Spaceship 2 videos where people are paying almost $250,000 to fly up and experience zero
What it
G.
means to be in space. Yes.
Yes, you have
Yeah.
that kind of a thing. And then the other
Right.
projects, and along the way, like I said, you could do so many learn things. You work with the team of people. Some guy will come to your cubicle and say, I'm doing this. How can you help me with that? So you sit and learn what he is doing to help him, things like that. So it was kind of a nice atmosphere. And
No,
then my
amazing, Bala. Typically in this show, there is. I used to get feedback saying, tell me about salaries and how progress." But what you've just described is attitude, skill, and the openness to learn, which you can't put a money value on. You can say that you can't take 20 different professions and then give career paths for each of them. So I think what you're emphasizing is that be hungry to learn, take the risks, and then
yes.
whatever way life takes you, you will find interesting things to do.
So here's an example from that part of it. Normally,
Okay.
when I say I moved from the Bay Area company to the San Diego company, they didn't have a
Yeah.
position that fit my resume. So
Okay.
I talked to them and said, "This is what I can do for your company. These are my skill
Okay.
sets, and this is how I can." I managed to get an interview, and they created a position just for me, and the pay scale was a senior pay scale. So it depends on
Yeah.
what you learn and how you use the knowledge you have. To
Right.
it's like you don't want to stagnate your mind basically at any point
Right.
of time. So at every point of your career, you start looking at what am I learning and how can I make it better. That is always the motivation. Money is a good factor, but you got to understand the more you know, the more value you carry as far as the monetary aspect goes. So if you are valuable enough, company who's there, even if it doesn't have a job posting with your match, they will create a job post. Again, networking helps a little bit in that
Yes.
part of it
Yes.
also.
Yes.
So
Yes.
because even to get that access to do that, you can say somebody you know in the company, hey, I'm looking this. Can I talk to somebody? You can ask that. So that's how you basically networking is very important in especially these kind of areas. Again, it's common nowadays, but it is very essential in a high tech field like this. So that's how salaries are pretty high compared to not compared to the Bay Area salaries, more compared to other regular industry salaries, like say for instance
Right. Right.
automotive industry, it's much higher than that. Because they are,
Right.
like I said, they call it rocket science. No, it is rocket science. You get knowledge,
It's rocket science.
you get paid
But
for rocket science.
the wonderful part of what you just explained is that you don't have to start with aerospace. You can start with chemical, mechanical, electrical,
Yes.
anything. And then, depending on what your skills are and what your interests are, you can begin to chart out a course saying that, okay, in this industry, you can go down a rabbit hole, you can expand your horizon, and then say, I want to learn this, this, and this. And the money you make will be commensurate with the amount of learning. What I think that simple aspect which you said, you
Like I
get
said,
paid for what you know, which is,
when
yeah.
whenever I move or to the next job, basically again this field is kind of finicky, especially in the US in the sense the most of the programs are funded programs. So if the
Right.
funding stops, then your program is kind of going to get slashed. So that's where
Okay.
the uncertainty level is. But
Okay.
the thing is, the next job is always there in a different part of the company or something. And the next job will always carry at least a minimum of 10% increase in your pay scale. So that is
Okay.
the best part of the thing, where you are not going parallel in the pay scale area. You are more climbing up in the pay scale area. So that
Like a
is the
rocket, it's going up as well.
yes.
Okay. So, in terms of your approach, from whatever I've seen so far in the conversation we've had, you took a risk early on. You decided that simply because you had worked for 8 years, nothing prevented you from going back to college again and then trying to figure things out. And then you made the best of what you had in addition to building your network and not remaining confined to one area. So In a sense, it's a combination of being a generalist while being a specialist. You have these hybrid areas today, which you spoke about in rockets, that entire domains are fusing. It's not as if you did one thing and then you managed on that all through your life. You have actually switched, you have learned. And I think this unbounded curiosity, where you work on the shop floor, you see someone doing something interesting, and immediately you say, okay, what are you guys doing? And then that is part of whatever you do.
Oh, there is even I can make a joke about it. I tell people
Uh,
I get paid for burning things, literally. The only thing is I have to make sure that I get to burn them properly. So, so,
okay, okay, yeah,
uh,
that's a wonderful way to put it, because I've also heard this description of rockets as basically you're flying on a bomb. It's a controlled explosion. There is no other way to put it, because it's not anything within the realm of the temperatures or the burning capacities that you're familiar with, because to get out of into space requires dynamics of a completely different kind.
not only that, nowadays, if you look at it, previously, rocket means you had 100,000 components basically. So if it fails, you
Okay.
don't know where the failure point is. Nowadays, the technology is so improved. So you have things like additive 3D printing, manufacturing, where your 100,000 components are reduced to 10,000 components.
Oh,
So basically, those are things, areas where, like I say, any guy who's doing a mechanical, chemical, manufacturing engineer, 3D printing, that's a new thing which is being done nowadays. So those are areas which weren't there now. Then are now kind of the next frontier,
available to you.
basically.
Right.
Yeah.
Right.
Like I said, we did a lot of this work, and when like I said, last part of my career before moving back to India, I spent 2.5, 3 years starting a German startup. I spent it in Germany with a company started by very young people, 25, 30-year-old people. I was like the guru for them to get this product, and we did launch finally. I wasn't there, but they did. It took them 2.5, 3 years to get to the point. I helped them, and finally last year they launched the first hybrid rocket from Australia. Unfortunately, Europe does not have a launch facility till, so they launched it from Australia. But it was there. You can go to the YouTube and see the launch of the. It's a company called High Impulse that I worked at. They did launch it. So.
Okay. Okay.
mm,
Marvelous,
uh,
Bala. Thank you. I think we could go on and on, but at least I think you've given people an idea of what does a career in rocket science mean. And essentially, these episodes are meant to be the launch pad for any career. That is, people listen to real people who have gone through these careers and then figure out that, hey, I know how it happened for them. So maybe there is a chance for me as well. And that is
like I
where it
said,
starts.
when we were students, there only used to be aerospace engineering in the IITs. There was nothing else elsewhere. And that too, I think
Right,
Bombay IIT had the only aerospace institute.
right,
Chennai had one. The
right.
rest of it, there was no concept called aerospace at all. Nowadays, every university in India produces a lot of aerospace students, and I have given a lectures in a couple of universities in India, and it's really happy to see that at least 50% of the people pursuing them come from the were women who were trying to girls who are trying to get into the field, which is a very promising sign of where things go. Like, for instance, most of your ISRO control systems and all of
Are
them
all
are ladies who are, yeah,
women.
which is
Yes, yes.
a lot, plenty of opportunities in this field.
Wonderful.
Thanks for the opportunity, Venu. I hope your viewers have got some basic idea of what you can expect as opportunities in this expansive field. But let me conclude by saying I told the story about meeting this person on the train and him motivating me to look into this field called aerospace. I did get to meet that person many years later, actually in 2009, when he made a visit to the US. But by that time, he had become the president of India. So there needs to be somebody who needs to motivate you, and you
I
always
mean,
have to
that
find
is
somebody.
one amazing bit of information that Abdul Kalam is the one who, just shared his experience on a train, and it
He was
reached a point where he inspired you for life.
I
What a
think, a
wonderful
director.
story.
Yeah, he was the top official at the DRDO at that time. Very simple person, but he spent about 45 minutes talking to me on that. And I did get to meet him, but that time it was quite difficult after he became president because there a lot of security apparatus around him. But even
Right,
there,
right.
apparently, one of the security people was a person from Tutukorian. So I spoke to him in that Tutukorian Tamil, and he immediately got me a chance. He did remember, but not as he did remember, not as much as, but we did
Yeah.
keep in touch through the email.
Wow. Amazing. Thank you, Bala. That was a wonderful end to the episode, and I think it's one of the amazing bits of coincidence that you cannot sort of plan for in a lifetime. These things happen. Yeah.
Thanks, Venu.
Thank you again for coming on the show.
Yeah, thanks,
Okay.
Venu.